I will now perform a demonstration of the Matlab algorithms that were created for each of the types of fingerprint recognition. The first type of fingerprint recognition that will be demoed is the correlation-based matching. First, I will show the pre-processing that was performed in the correlation-based matching. So here we have one of the images in the database that could be read in to be used for this matching. The fingerprint looks as follows. Then, after the pre-processing, it would appear to look like this. Notice in the second image, compared to the first, that all of the details in the fingerprint are now in black and white rather than on a grayscale, and they are also in a serious contrast in comparison to the background of the image. The type of pre-processing that was performed in this image involved resizing the image from a 480 by 640 to a 512 by 512 pixel image. Then histogram equalization was performed to bring out the contrast in the details in the fingerprint. Finally, binarization was performed to convert the image from a gray level image to a black and white image. Now I will demonstrate the one-to-one matching that could be performed using the correlation-based matching. So you would select two different fingerprints to be matched. In this case, they are copies of the same print, as you can see, with the 101 in each of the images. It says there that the fingerprints match, and it took 0.093 seconds to perform the matching. I'll show another example of this time from image 3. Two various copies of this, and you can see once again that it shows that they match with a time required of 0.096 seconds. This algorithm can also be used to accurately demonstrate if the fingerprints do not match when they shouldn't. For example, if we compare a print from image 4 with the print from image 5, we can see that it says the fingerprints do not match. Another example would include matching the print in image 4 to possibly one in image 6. And you see once again that they do not match. For the one-to-all matching, it would take in one fingerprint as the input and compare it to each of the fingerprints and determine which provides the best match. When performing this form of testing, only the first image as a copy of each of the 10 different types of images was used so that a consistent representation of one-to-all matching could be used when comparing the first three types of algorithms to the neural network algorithm. I will now demonstrate the one-to-all matching. So we'll select one from the second image. And we'll see here that it matched it to, once again, the second image, and it took 0.462 seconds. We'll try that again, this time with the third image. We can see there it matched it to the third image in 0.466 seconds. I will now move on to minutiae matching. First, I will show what the image looked like for one of them before any form of pre-processing. As you can see here, it's just the standard grayscale copy of the image. And then the first step in the pre-processing includes reading it in as an input and performing hold on one second. First, I'll read this in as an input. Where are the function names? Hold on. Now we can see the pre-processed image. As you can see here, all of the ridges have been thinned down to 1 pixel, and the image is now in black and white. This thinning allows for the minutiae to be measured as only 1 pixel wide, so they can be more accurately paired up in the next image. I'll now demonstrate the one-to-one matching that can be performed with the minutiae matching code. I will select 2 images from the first fingerprint, and we should see that they do match. This form of fingerprint matching takes a while, if you remember from the PowerPoint, around 16 seconds or so for each one-to-one matching, which is quite a long time, hence the reason that this type of fingerprint matching is looked down upon. As you can see, it says that the fingerprints match, and it took 16.74 seconds. We can also do a test for ones that should not match. We'll grab one from the second type of fingerprint, and then one from the 8th. And wait about 16 seconds, and we should see that they do not match. And there we go, they do not match. One-to-all matching using the minutiae matching algorithm takes just about 3 minutes for one fingerprint to be matched to all of the other images. I will demonstrate that now. This type of one-to-all matching is performed in the same way as the correlation-based one-to-all matching, meaning that one of the images is selected, one of the copies of each of the 10 types of fingerprints is selected to be matched against so that it can be consistent with the neural network-based one-to-one matching. Since this takes about 3 minutes, I'll go on and explain the next type of matching that will be performed. The next matching that will be done will be based on the feature-based matching. Feature-based matching has a bit more developed pre-processing algorithm than the other types of matching. In the feature-based matching, Gabber filters, 2 different Gabber filters are used for edge detection. These filters help detect the edges in the image, which in this case are the ridges. With these filters, the image is then split into 2 different copies. One of these copies contains all of the vertical ridges, and another contains all of the horizontal ridges. When this test finishes, I will demonstrate how the Gabber filters are used and show the horizontal and the vertical ridges that are grabbed. Then, with the feature-based matching, I will demonstrate one-to-one matching based on the average vertical and horizontal distances between the ridges in each of the fingerprints. Like I had mentioned earlier, if the horizontal and the vertical ridges differ by less than 1.33 pixels each, then the 2 fingerprints are said to match. When I get to the one-to-all form of matching for the feature-based matching, it took the magnitude of the horizontal and the vertical average different distance between ridges and used that magnitude to compare to all of the different magnitudes of the distances in the database. And that will be demonstrated also. should be finishing up soon. You can see why the minutiae matching algorithm was not selected as one of the best algorithms in my analysis, based on this extremely slow timing performance. As you can see, it took 171 seconds to perform this match, but it did match accurately that the 10th image compares to a copy of the 10th image in the database. Now, to demonstrate what I had mentioned about feature-based matching, so we can read in an image. Oops. View that image as this grayscale copy of the image, and then prepare the image using the Gabber filters and the pre-processing. I will show now each of the two copies of that image. So this shows all of the vertical ridges, and then if you check the second, then you see all of the horizontal ridges. Now, in the final pre-processing, each of these ridges was thinned down to 1 pixel wide so that more accurate distance could be calculated. I'll now demonstrate the one-to-one matching. Selecting 2 images from the first, 2 copies of the first image. You can see the fingerprints match took 1.21 seconds. Show another variation of that using copies of the third image. Once again, you see that they matched. You can also use this to determine when images should not be matching. You can see here, we'll just switch to the 8th, and we can see that they do not match. Now demonstrate the one-to-all matching. Takes about 10 or 11 seconds. And you can see that it matched a copy of the 5th image to the 5th image in 11 seconds. In the third video, I will demonstrate the functionality of the neural network.